everyone, I'm Erfan and welcome to my channel. The paper I've selected today to go through with you guys is the Add Math paper from May-June 2024. This is paper 1, time zone 1. So without any further ado, let's go ahead and start with question number 1. In question number 1, part A, I'm given this cubic equation and I'm asked to sketch the corresponding graph. So since it's already in a factorized version, all I have to do is to just put all these factors equal to 0 to find out the roots. In other words, the x-intercepts, which are half, -2, and -5 respectively. I also have to find the y-intercept. You can do that by just equating the x equal to 0 and then find the corresponding value for y in the original equation of the curve, and that is 2. So some students here struggle how to do the graph. A good rule of thumb here is that if the coefficient of your leading term, in other words, the number in front of the x cubed term, if it's negative, your cubic curve is gonna have a shape something like this. And if it's positive, you come into the page from the top right corner and you have to leave from the bottom left. So since this is the case, you just follow and connect the critical points which you found up here. In part B, I have to make use of the sketch that I just made and solve this inequality. So this cubic is greater than or equal to 0. So if I just refer to my graph, that means all the portions that fall above the x-axis, it's this region and this region. So all the x's less than -5 satisfy this inequality, as well as all the x's that are bounded between -2 and +1/2, including those because I'm considering also everything that is equal to 0. And that is the answer. Question number 2. In question number 2, I'm given a polynomial p, which is a cubic polynomial, and I have to write it in this format where qx is a polynomial itself and the value of the qx and r has to be found. So this is a matter of long division. You can just perform long division to find out the qx and r is basically the remainder. So I believe you all know how the long division is done. So first thing first, how many 2x's can go into 6x cubed? So you can put your focus on the numerical part first. That would be 3 times 2 is 6. Also, what should I multiply x with to get x cubed? That would be x squared. Therefore, the first term here would be 3x squared. You multiply it by 2x, you get 6x cubed. You multiply that by -5, you get -15x squared. However, you need to subtract it from the expression above. Once you do that, the x cubic term is gone. However, the x squared term is now -20x squared. So you bring the next term down, which is the x term. And then you basically proceed the same thing. You ask how many 2x's can go into -2x squared. So that's going to be -10x because I want to have an x squared term here. You multiply that by 2x and then you multiply it by -5 and you get positive 50x. You need to subtract it from the expression above and you end up with -16x. You bring the constant down now. And lastly, how many 2x's can go into -16x? That would be -8. You perform the multiplication again. The x term is gone and now you're only left with the remainder. So r would be 5. So my qx would be 3x squared minus 10x minus 8. In part B, it says, hence write the expression px minus 5 as a product of linear factors. So I've already obtained p of x here. Now if I subtract 5 from it, the remainder is gone. Now all I have is a linear factor and a quadratic, but since they ask for all to be in linear factors, you need to factorize this quadratic further into two linear factors. You can use box method. I believe this is a quite easy factorization. So since this is a prime number, definitely one of them has to be 3x, the other one x. Then you ask yourself, two numbers, their product is negative 8. So in this case, it takes a little bit of time to master the box method. You can check out my other videos how to do factorization of a quadratic expression if you don't know how to perform this factorization. In part C, we are asked to write down the solution of the equation p of x equals to 5. Now that I know p of x minus 5 is basically this expression. So it's the same as solving what I found up here, because after all, if you move 5 to the other side, you get p of x minus 5, and that's exactly what I found up here. So you just put it equal to 0. You got three linear factors. You put each one of them equal to 0, and they lead to three distinct answers, which they're all acceptable since there is no limitation on the value of x. Question number 3. I have to write this expression as a single logarithm to base 10. And this is quite a common question. If you go through the past year papers, you will see this question very frequent. So I'm going to be using the law of logarithm, which allows me to combine these three. The first one that I'm going to take care of is this subtraction. So if you want to rewrite this as a single logarithm, you can use this law, which says you need to divide basically the arguments if you're dealing with subtraction, and if you're dealing with addition, you just have to multiply the argument, and that's what I did in the third row, as you can see. However, before I do that, I did a little bit of simplification here. So x squared minus 1, I can use the famous identity of difference of squares and write it as x plus 1 times x minus 1, because after all, this negative 1, I can just lend a tiny 2 to it, and it's not going to change the expression. Also, x minus 1 square, it basically x minus 1 times itself. So therefore, x minus 1 and x minus 1 is cancelled from top and bottom, and you left with this. And lastly, since this is plus, you just multiply 10 to the numerator here, and that's the final answer. In part B, I have to solve this logarithmic equation, and I have to make sure my final answer is in exact. In other words, I must have a cert there where A, B, C is to be found. So when you look at this logarithmic equation, the first thing you notice is the bases are different. You can make the bases the same simply using the technique where if you want to use a new base, all you have to do is to follow this formula. So let's say C is my new base. So B is here now, and then C goes down there. So if you do the same thing here, in the numerator, you get logarithm of 5 to the base 5, because I want everything to be in the base 5, same as the left hand side. And logarithm of anything to its own base is basically 1. Logarithm of 5 to the base 5 is 1. And 9 was already there, so I leave it there. Now that I have two identical terms, I can do cross multiplication, so the power is raised to the power of 2. I bring 4 to the other side, it goes down, so you perform cross multiplication here. And then lastly, I have to get rid of this 2. I can take square root from both sides, which leads to a plus minus 3 over 2 So that gives me two different paths. The first one, well, according to the definition of logarithm, 5 to the power of 3 over 2 should give me x plus 1 here. Also, one of my answer was negative 3 over 2. Therefore, 5 to the power of negative 3 over 2 should give me x plus 1. And then from here, I need to make x the subject of the equation. So therefore, I get x is 5 square root of 5 minus 1. On the other hand, I have to deal with 5 to the power of negative 3 over 2, which you can bring it down, make the power positive, and then go back to the conventional way of showing it as a surd or the radical sign, because that's what they ask in the question. And if you do that, all I have to do is get rid of the 1, you bring it to the other side, become negative. You can leave it like that, but you can also combine the fractions, combine these two, but I think that's sufficient, and that's where you can stop. Question number 4, part A. The first three terms in ascending powers of x in the expansion of 3 plus px raised to the power of n is this, and n, p, and q are constant, and we have to find the value of them. So this is binomial theorem basically, where you need to expand this binomial up to the first three terms and then make a simple comparison to find those values. So let's go ahead and apply the formula. So the first coefficient is always nc0, followed by nc1, followed by nc2. And what happens to the first term? We start with the highest power, and then as we proceed, we subtract 1 each time, unlike the other term where you start from 0 and each time you add by 1. So these are the first three terms I got. So NC0 is basically 1. This thing to the power of 0 is also 1. So my first term is literally just 3 to the power of n. NC1 is n, and also here px to the power of 1 is just px, and you don't need a you cannot even use a calculator here because it's n, right? So you have to make use of the formula for NCR, which is basically n factorial over n minus r factorial times r factorial, and that's what I did here. So n factorial divided by 2 factorial times n minus 2 factorial. So that's where the n minus 2 factorial from top and bottom is basically canceled out. And that's why I'm left with n times n minus 1 divided by 2. And don't forget that also this power belongs to both terms p and x, and that's what I got here. Now you just have to make a comparison constant with constant. So this is the only constant here. Therefore, 3 to the power of n has to be 243, which leads to n to be 5. And then moving on to the next term, 810 is the coefficient of my x. Therefore, this thing should be equal to 810. However, I already found the value of n. I can make a substitution for that, and therefore p is just simply 810 divided by 405, which is 2. And now that n and p are known, we move on to the last term, which is qx squared. So therefore the coefficient of the x squared term has to be equal to q. But since I found the value of p and n in previous part, you just make a substitution for that, and therefore q is 1080. In part B, I have to find the term independent of y in the expansion of this binomial, which is raised to the power of 6, and I have to give my answer in exact form. So if you're aiming for a specific term, all you have to do is to start with the general term, which says nr a to the power of n minus r, b to the power of r, and this is basically the expansion of a plus b raised to the power of n. So this is the general expansion, maybe it was better if I put sigma in front of it, since it's the formula. Okay, that's better. So this is basically the general formula for binomial, and any term in the binomial basically follows this format. So we start with that, and R is to be found basically. As soon as you find R, then you can tell which term is independent of Y, or in other words, which term is just a constant. So the trick is to gather all the constant one side and variables on the other side. As I color coded here, you just expand this bracket. The power of everything, top and bottom, should be R. However, you have a negative 1 over 3 raised to the power of R. Don't forget that, because we don't know whether R is odd or even. Therefore, you have to keep the negative there. And I think it's also clear that how I got the y to the power of 6 minus r, it's from here. There is a y there. There's also another y there. And I prefer to bring the to the power 2 up. So therefore, I change it to negative. Now, if you want to find the independent term of y, so that means the power of y should be 0. That means this thing, when you combine it, there's addition and have to put it equal to 0. Therefore, that leads to the value of r, which is 2. Now that I know the value of r, you just go back to the same formula you started with. Now you just target the coefficient or the constant part, not the variable part. You make the substitution and you get the final answer, which is 80 over 3. Question number 5. I'm given the diagram of this cosine curve, and I have to find the value of the constants A, B, and C by investigating this graph. Where the first two things that you can recognize just by looking at this curve is the amplitude and basically the principal axis. So the principal axis is between the maximum and minimum point, so that would be -4, and that's responsible for the vertical displacement of this curve, because cosine curve, the principal axis is the x-axis itself. So it's very clear that we move down 4 units, therefore C is -4. Also, A is responsible for the amplitude. You just have to figure out how far it is from this middle point. From -4, you have to go 5 units up to get to the maximum, or 5 units down to get to the minimum. Therefore, A is 5. Now it's down to finding the value of B. So since we're dealing with a cosine curve and everything is in degree, so the formula says you divide the 360 degree by B, which is the coefficient of x, and you should get the period. And if you look at the curve, you can take two corresponding points on 2 cycles. So what I chosen here is the 2 minimums. You could also use this point and this point. So the goal is to find the distance between them. And in this case, this is -240 and this is 240, so they are 480 apart. And you do a cross multiplication. B is 360 over 480, which is 3 over 4. In part B, we're told that a line y equals to P is a tangent to the curve y equals to 3 minus 2 sine 6 theta, and I have to write down the possible value of P. Well, it might sound a little bit difficult at first glance, but if you recall any sine or even cosine curve, they have a maximum and minimum point. And if you want the y to be P, and any line in this format is a horizontal line, if you want it just to touch the curve, basically just to be the tangent, that means it either has to touch the maximum point or touch the minimum points. So All I have to do here is basically just to find the range of my curve here, take the maximum and minimum. Those 2 points are the answers. Here is 1 and 5. But how did they find it? Well, sine function, it can get any value from -1 all the way to +1, right? So if you want this expression to be maximum, so you have to think of a number which makes this -2 +2. Therefore, with 3, you get the maximum out of it. So the only number I can think of is -1. So if you want it to be minimum, you should not go for 0. Some student, unfortunately, they think they get the minimum out of this if they choose 0, and that is not correct. But you have to, since this is -2 and I want the maximum number that I can take away from 3, so if I multiply it by +1, I have -2 here, and 3 minus 2 is 1. Therefore, the range would be between 1 and 5, and those are the 2 points or the two values for P that the question is asking for. Question number 6. In question number 6, I'm given this expression and I'm supposed to take integration of it, and I have to leave my answer in exact form. So the first thing I'm going to do, I'm going to split this up because I have two fractions, so I can just investigate them individually. The first one, it's not an issue. After all, when you look at the denominator, the derivative of the denominator, which is 2, can be found in the numerator. Therefore, I can use this formula right here, and the answer for the integration is just the natural log of the denominator. However, for the second integrand, you have to use the technique called integration by substitution. So I'm just gonna take this 3x minus 5 to be the variable u. Obviously, I'm doing this because of the power 2 here. I cannot use the same technique which I did here. So once you call that u, you need to change everything, get rid of all the x's, and change the whole thing to the word into the word of u. So if u is 3x minus 5, therefore du is the derivative of the right hand side is 3 dx. So the 3 dx here can be replaced by du, and 3x minus 5 is replaced with u. Since the power is 2 and since it's in the denominator, you bring it up, it becomes -2. Now we can take integration of this. It was probably better I changed the limits of my integration here, but since I changed it back to the word of x, so I kept on to those limits of integration. But remember, if you are changing to the word of u and you want to continue with that, then the limits of integration should be changed accordingly. Means if x is 2, therefore u has to be 6 minus 5, which is 1, and when x is 4, u has to be 12 minus 5, which is 7. So it was better if I write 1 and 7 here, but again, since I wanted to change it back to the word of x, so I kind of hold on to those limits. But take note of what I just mentioned here, because that's where the common mistakes happen. After you take integration, you just use the limits of your integration here. You make the substitution. You have ln 5 minus ln 1, which is basically 0. And you have 1 over 12 minus 5 minus 1 over 6 minus 5, which is also just 1. And you simplify, you get this ln 5 minus 6 over 7. In question 7, I'm given this equation, and also I'm told sine theta is the square root of 5. I have to find y in terms of x. In other words, I have to get rid of the theta. Okay, so let's start with what we have. I made cotangent theta the subject of the equation. I raise it to the power of 2. You're going to see why in a minute, because then I want to use this identity which relates cotangent to cosecant. And don't forget the cosecant is also 1 over sine theta. And that's how I made the connection between cotangent theta and sine theta eventually. So once you get here, I'm going to add 1 to both sides, right? After I raise it to the power of 2, of course. Then once on the left-hand side, I have 1 plus cotangent squared theta. I can write it as cosecant theta square, which is nothing but 1 over sine theta square. And on the right-hand side, I still have the same expression. You do not need to expand it. However, if you do, it's fine. Then you basically cross multiply or flip just the both sides, make the reciprocal of each one of them. You get sine squared theta is 1 over this expression. And since sine theta is a square root of y, that means sine squared theta is basically y. So therefore, y is equal to this fraction. Question number 8. In this question, I'm given a trigonometric equation and I'm supposed to find the value of alpha, while the alpha is between negative pi over 2 and pi over 2. And obviously, since everything is defined in terms of radian, I'm supposed to give my answer in terms of pi as well. Now, first thing first that I always prefer to do, instead of introducing a new dummy variable into my question and call these, for example, a, because some people do that, I actually rather to keep whatever that is here as the argument of my trigonometric function, go ahead and change my domain according to that. Since alpha is bounded between negative pi over 2 and pi over 2, therefore 2 alpha should be between negative pi and pi. And then if you just subtract negative pi over 3 from all sides. So now this is what I'm targeting for. You will see in a minute why this comes handy, because this is a trigonometric function and usually students ask, where should I stop at which answers? Because there are infinitely many answers, and especially if the domain is in this format, it could be a little bit tricky. So now that I did that, let's start with isolating my sine function on one side. I have to get rid of the 4. Therefore, I'm going to divide both sides by 4. Then I have to remove this power 2 here. So I'm just going to take square root from both sides, resulting in plus minus half on the other side. Then I have to take inverse sine of both sides. And this is quite a famous angle. For positive half, we get, if you look at the unit circle, this is pi over 6 or 30 degree. That's for positive half. Also, we have 5 pi over 6 because it has the same height, but it's located in quadrant 2. Therefore, the answer would be these two. However, since the domain here, 2 alpha minus pi over 3, should be between negative 4 pi over 3 and 2 pi over 3. So this is exceeding my domain, and this is not acceptable. However, I'm going to go ahead and replace it with negative 7 pi over 6, because first of all, this is within my domain, right? This is less than negative 4 pi over 3. And also it's the same point, but I'm looking at it from the other direction. Basically, I'm going this way to reach the same point rather than going 5 pi over 6. I'm going negative 7 pi over 6. So this is exactly why I said at the beginning, before you start solving, you better change your domain, because this way you won't miss any answer. For the negative side, we do the same thing. We have negative If I draw the unit circle again, I got negative pi over 6. I also got negative 5 pi over 6, and I don't have any issue with either of them because they are within the domain which is defined here. And then one by one, you remove the negative pi over 3 by adding pi over 3 to all sides, and then divide everything by 2 to remove the 2 in front of alpha, and you're left with alpha. You do the same thing over here. Therefore, you end up with 4 answers for alpha, and they're all valid. Question number 9, part A. I'm given this simultaneous equation, which is defined in terms of x and y, and I have to find the value x and y. Obviously, elimination is not an option here, therefore I have to go with substitution. However, before I do that, I have a tiny problem here because x and y is in the power. I have to bring it down. So I'm going to start with uniting these two terms since the base is e, so I can just combine them and add up powers and then take natural log from both sides, so therefore I can bring it down. As you all know, ln e to the power of x is the same as x, and natural logarithm of 1 is 0. Now this is in version that I can work with and start the substitution. So I have to make y the subject of the equation. So I pick up the top one, make y the subject of the equation, y equals to 4x. Go to the second equation, replace y with 4x. Therefore, I end up with a cubic equation. I divide both sides by 4 to isolate the x. Now I just have to take cube root from both sides, which results in 4. So if x is 4, all I have to do is go back to this equation, which is the simplest one to work with. You could also substitute here, but that's not really a good idea. So choose the simplest one. X is 4. 4 times 4 is 16, and that is the value of y. Question number 9, part B. I'm given this exponential equation in terms of x, and I'm supposed to find the exact value of x. So at first glance, when you see the power of e here, that is 2x minus 1, but here is the negative version of that, which is 1 minus 2x. They're basically the same, except you have to go through a little bit of change in order to make the same. You can bring this down, make the power positive. However, you need to multiply that by a negative. So you get 2x minus 1. And then once you do that, these two are exactly the same. So I'm going to multiply both sides by e to the power of 2x minus 1 to get rid of this denominator. As soon as you do that, the power here is doubled, and we have e to the power of 2x minus 1 in front of the 11, the constant, and now on the right hand side I'm only left with a constant. Bring everything to one side, and if you examine closely, you realize that you can take a 2 out here, and actually once you do that, then this is nothing but an exponential, nothing but a quadratic equation. And the way you can approach it is to basically introduce new variables such as y and call it e to the power of 2x minus 1, and then it become more obvious that this is a quadratic equation to be solved. So over here you can use box method, you can use even quadratic formula. I rather to do factorization using splitting the middle term. So negative 11y can split up to negative 15y plus 4y. You might be wondering where those numbers come from. Well, I calculated the AC, so this is A, this is C, so therefore you multiply that and you get negative 60. And I'm looking for two numbers where their product is negative 60 and their summation is negative 11. And those numbers are negative 15 and positive 4. So once you do that, then you can group them together and then factorize. So the biggest factor that I can take out here, that would be 5y. It's going to leave me with 2y minus 3. Over here, I can factor out 2. That's going to leave me with 2y minus 3. And once you do that, you see we have a common factor here, and that's the last factorization you're going to do, and you end up with 5y plus 2 times 2y minus 3, which is 0. You're going to put each of them equal to 0 separately, and that results in the two answers that I have obtained already here. But don't forget that y was your intuition, so and you introduce it into the question, and you have to get back everything into the word of x. So y is e to the power of 2x minus 1. I'm going to replace it with that. For the first solution, actually this is invalid because exponential functions, they can never be negative. For the second one, however, it's valid. You can continue. Same thing. I want to remove e. I have no choice but to take natural logarithm from both sides. That results in having 2x minus 1 on the left hand side and natural logarithm of 3 over 2 on the right. And all you have to do is just to remove the negative one, push it to the other side, become positive, and divide everything on the right hand side by 2. Therefore, this is the answer for x, and that is the exact form which is required in the question. Question number 10. So we have a particle called P, and it is at a fixed point O at time 0. The velocity function for this particle is given as 3 sine 2t, where t is greater than or equal to 0. I have to find the exact value of t for which the velocity is 0 for the first time after P leaves O. So obviously, since they're asked where the velocity is 0, and this is my velocity function, you just have to put it equal to 0 and solve for t. However, this is a trigonometric function, so I'm going to end up with infinitely many answers. But since they said the first time, I'm going to just choose the first one. If 3 sine 2t is equal to 0, therefore sine 2t should be 0. And we all know that sine is 0 at 0, pi, 2 pi, and etc. However, I did not put 0 here because they said for the first time after it leaves position O. You can ignore that solution. So therefore, the first one would be this guy, pi, and t is pi over 2, which is in second, and that's the first time after P leaves O. In part B, I have to find an expression in terms of t for the displacement of P from O at time t. As you all know, the displacement can be found by taking integration of the velocity function. So I'm just going to go ahead and substitute the velocity function here. I have to take integration. This is quite an easy integration to do. The integration of sine 2t is negative cosine 2t. However, don't forget to divide it by the coefficient of t, which is 2. And then also don't forget the constant of integral. Now I have to find the value of c. I can do that because I'm given an initial condition. I'm told at time 0, the position of the particle is at origin, or in other words, the displacement is 0. So I'm just going to go ahead and replace s with 0 and t with 0. Therefore, I get cosine 0, which is 1. 1 times negative 3 over 2 is negative 3 over 2. And you push it to the other side, you get c to be 3 over 2 or 1.5, and you go ahead, rewrite this thing, but now we know the value of c. You just replace it with 3 over 2, and that is my displacement function. In part C, I have to find the distance traveled by P between 0 and pi. So the approach I used here is that I just basically graph it, and I did it step by step. I'm going to walk you through it. It's not really a hassle. It's not scary. It's actually easier than you think. So let's start with cosine t and then add all these guys one by one to it. So cosine t from 0 to pi looks like this, the green one. And then I'm gonna change the amplitude to -3/2. However, when you do that, you have to flip it because of the negative sign. You need to mirror it about your time axis. At the same time, you stretch it. So the new position of maximum and minimum points are going to be 3/2 and -3/2 respectively, rather than 1 and -1. Then I'm just gonna change the period. That means I'm gonna multiply t by 2. That's gonna cause my function to be shrinked by a factor of 2. As you know, the period of cosine function is 2 pi. However, when we have a coefficient here in front of t, which is 2, you need to divide it by that. You get the new period, which is pi. So from 2 pi, when you go to pi, you just basically shrink it. That's what I did here in purple. So from the red, now we move on to the purple one. So that means we have one cycle from 0 to pi rather than half a cycle which we had just earlier. And lastly, I'm gonna apply the vertical shift upward. I have to move all the points 3/2 units up or 1.5 units up. Therefore, my maximum from 3/2 is going to change to 3, from -3/2 to 0, and from -3/2 over here to 0 as well. So, and you get this bell-shaped curve. Now, why did I go through the hassle of sketching this graph? Because this is the displacement graph. And if you want to find out how much you have traveled or how much it's been displaced, obviously this displacement is 0. But if you want to find out the distance traveled, this shape is actually symmetrical. So if I just find out how much the displacement was from 0 to pi/2, I just need to multiply that by 2, and that's going to give me the answer 6. Question number 11. The tangent to the curve y equals to 3x minus 1 raised to the power 1/3 at the point where x is 3 meets the coordinate axis at points A and B. The point with coordinates A and A lies on the perpendicular bisector of the line AB. Find the exact value of A. So what's basically going on here, we have a tangent at point equals to 3, which is going to cut the x-axis as at point A and B. So before I continue with the rest of the question, I need to find those 2 points. And in order to find those 2 points, I need to know the equation of my line. Therefore, I can make the substitution to figure out those 2 points. And in order to find out the equation of any line, you need either 2 points given on that line, or you need a point plus the slope of that line. So therefore, I'm going to just go ahead and take derivative of this curve. So that helps me to find the slope of the tangent. Once you're taking derivative of this curve, you have to be careful because there is chain rule involved. Basically, derivative of outside, which is the power subtracted by 1. However, don't forget to bring the power down and then multiply by the derivative of inside, which is 3. And this is what I get. All you have to do now is to make the substitution for x. So once you do that, you get minus 1, which is 8 raised to the power of -2/3. That's 1/4. You can think of it as the cube root of 8 raised to the power of -2, 2 to the power of -2, which is 1/2 squared, and that is 1/4. That's what I obtained right here. And for knowing the point, I just have the x-coordinate of my tangent point. I need to find out the y-coordinate. So I have to make a substitution into the original equation of the curve. That helps me to find the corresponding y value, and that is 2. So therefore, This point is basically 3 and 2. I'm going to be using the standard equation of a straight line. Now m is known, the x naught and y naught also known. You just make the substitution and you got yourself the equation of a tangent line. Now that I know it's cutting my axis at A and B one time, I'm just going to put y equals to 0. That helps me to find the x-intercept, and that is -5. Let's call that point A. They didn't mention which one is which, but you can call it B as well, doesn't really matter. And then I'm going to find the y-intercept, and we know that at any y-intercept x equals to 0. Therefore, in this equation, I'm going to replace all the x's with 0, and that's the y coordinate of point B. So now that I have point A and B, I need to find the midpoint of them, because this point we're talking about lies on the perpendicular bisector, and bisector is passing through the midpoint of A and B. And that can be found simply by adding the x's together, take average of that, add the y's together, and divide by 2. That's the midpoint. And now it's time to find the slope of the bisector. So if this is my line AB with the slope of 1/4, the slope of the bisector, which is perpendicular to AB, has to be -4 according to this formula. You find the reciprocal of that, you multiply it by -1. Then I can again use the formula for the straight line, make the substitution, and find the equation of a bisector. However, you do not need to tidy up. All you need to do after this point is to make the substitution for the point which lies on the line with x and y coordinate of a. So instead of y, I replace it with a. Instead of x, same thing. And we continue, make a the subject of the equation, gather all the a's on one side, and find the value of a, which is -15/8. And that's the final answer. Question number 12. I'm given the equation of a curve, and I'm supposed to find its first derivative, and I'm also told to leave my answer in this specific format where a and b are integers. Where at first glance you realize that the equation of a curve is a fraction, and the first thing that goes through your mind is to apply the quotient rule, and that's the right thing to do. There is another alternative. You can bring this x to the power of 2 to the numerator, but you have to make sure change the sign of the index to negative, and therefore you can continue with product rule. However, I prefer to start with quotient rule, and I have already color coded. These are the differences, these are the changes that happens after applying the formula right here in the corner. So first thing, the denominator is raised to the power of 2, and in the numerator you need to take derivative of the numerator. So that is a ln 3x. I have to apply chain rule. First thing I get is 1/3x times derivative of 3x, which is 3, multiplied by the denominator, and then minus the derivative of the denominator, which is 2x, times the numerator. And you can tidy up a little bit. However, you realize at this point I can factor out the x and then cancel it from one of the x's in the denominator, and that's exactly where I can stop. So therefore a is 1 and b is -2. In part B of this question says, hence find the integration of ln 3x over x cubed. So since they use the word hence, I have to get help from what I have obtained in part A. And as you all know, integration is the antiderivative. That means if I take integration of this expression, I should get back the original equation of the curve, and that's what I wrote here. And somehow I need to extract this guy from what I have here, this integrand. So the first thing I'm going to do is to split the fraction because I have a common denominator. Therefore, I'm allowed to do that. I'm also going to push this -2 outside my integrand. Therefore, I'm going to be left with this, and I have already color coded to track it easier. Then I have to take integration of this guy. The integration of 1 over x cubed can be found easily by bringing the power 3 up. You have to make it negative. Then you add 1 to the existing power and then divide by the new power, which is -2, and that's what I got here. And then you need to move it to the other side. The sign from negative changes to positive, and also you need to get rid of this -2. That means you have to multiply both sides by -half. But since I have already taken integration here, don't forget that there should be a constant. You could have added it right here once you took the integration, but I rather to just add it in the end. But it really doesn't matter as long as you don't forget. This is the correct answer.